Okay, so here's a basic demo of how to create networks with Delve. We'll start off showing you the fully manual way so you get the feel for it. You pretty much like Visio, you just drop the layers on there as your DNN node. We're going to do a CFAR, so it's 32 by 32 and the RGB like that. Then you would drop in batch normalization ReLU layer. So we've got a leaky ReLU. It'll be 64 filters coming in. Strider 1, filter with 3, that's fine. The next one, I need an add down here. So we'll join these guys up. Over here we'll put batch normalization ReLU. Like that, we join this guy up to there. Then we do another one. So we can actually do a drag and drop here. We just hold down. Copy that layer. This time this one's going in here. We've got 64 filters going in. Filter width of 1 there. These two together. This gets pretty painful doing it this way. There's a much better way in Delve to do this. So just giving you an example of how you have to do it manually. And next one's a conv batch normalization. 64 going in. 1. And then you're going to add this guy to here. And off you go. Then you would do a straight ReLU here maybe. So that's how you build it up manually. However, there's a better way. So we can just go new. You're not going to bother saving that. We'll do a new ResNet quick start. Basic setup of how you want the blocks to be put together. You can do all kinds of good stuff here. Change the way the branches work. So we'll just take the defaults and build a ResNet. There you go. The whole thing is made for you as per your input. All the appropriate layers are all put together for you. All you have to really do is go to the data layer and type your image size going in. It's RGB. And it's going to show you all the memory used on the GPU, each side of all the filters as it's coming through the network, and you can see the whole thing has been done for you. Okay, continuing this little tutorial, we've built our network, at least designed it. This is what I've loaded earlier, but we're going to go through the entire process. So for CFAR, you're going to need an XML file that describes the ground truth. We use Python to generate this. So you have an XML file, it will look like this. You can build this in any way you like, but this is the standard C CFAR10 database. So you've got the path name. We store it in a relative directory train images, and you've got all the file names and the ground truth for every one of those. There's like 50,000 of these or 60,000 of these things. It goes on for a while. So you'll load that guy up, you'll select that file. Then you're going to build your schema, which divides that data into the training set and the validation set. So we're going to create a new schema. We're going to use 5% of the images for validation. So we're just going to build a new schema, and we give it a name, and we call it CFAR 5%. Okay, so it's now built that, and you will get from that. Hang on a moment. Okay, so what happened there is it built a schema file for you. This is the CFAR 5%.xml, and there's two sections: the dataset type training contains 95% of the images. Some other keywords that tell the trainer whether this is an augmented images or not, so it can handle correctly augmented data. There's no augmented data in this set right now. We're going to do the augmentation within Delve rather than supplying augmented images in our data set, which we could do if we wanted to do that ourselves in Python. So the first section is dataset type training, and we search for that. There's 5% of the images are in type validation, and it randomly picked those from our input data. Okay, the next bit is to set up our solver. We can use standard stochastic descent. This is all good. That's a bit high for this, so let's do 0.5. We won't have any learning rate decay on this for now. What I tend to do is let it run for a while, see how it's doing. If it seems to have kind of gone a bit stuck, I may adjust the learning rate. The nice thing when you're starting off is to click this option which clears your batch normalization after each validation, so it gets you to where you want to be a little bit quicker. When you get close to the end, you turn that off and home in on your final result. Basic settings are fine for this, so we'll just go with that. So obviously a bit of data augmentation is always a good idea. So for here we're doing 5 augmented images for each input image. I've already set this up a little bit. We're not going to mess so much with the illumination. We're going to add some noise. We'll add some noise and the parameters. You can adjust the mean and the variance of the noise. You can add some Gaussian blurring. We'll do that. You can experiment with these values. I'll show you how to look at what the results of the augmentation shortly. I'm not going to do much on the histogram stretching. That's a way of really messing with color. Color augmentation here too, but we'll do that. We can go into more detail on how these functions work later. We'll do a little bit of translation and a little bit of scale augmentation just for the hell of it. This has got no audio data, so this is specific for our attempts to do text, speech to text. Let's do a few more. Let's do 10 per, why not? Okay, then you just go ahead and build a network. Well, we've set up our augmentation parameters, but it's always a nice idea to have a look and see what it's actually doing to our images instead of just blindly expecting whatever you type in to do something sensible. So if you right click on the data node, and you can select test data augmentation, and we'll select the images in our training folder. And this is the first one. Let's see, it did a little bit of a translation, a little bit of rotation, messed with the color a little bit, did some Gaussian blur, it didn't flip it, and it added a little noise. And we can cycle through these and see what it's doing, just randomly picking images and applying the augmentation as it would coming through the training. You get a rough idea. If you don't want to type in a parameter and have all the images black, that's not too good. You should at least still be recognizable as the input image, although that one seems to have gone a little too far. That's why you be careful with the illumination augmentation. They seem to be doing reasonable things. Okay, I'm happy with that. So we've built our network, make sure it's built. It thinks everything's good, so we should be able to start training if all's going well. So let's hit train. And it's off. I'm going to let it do the first 1,000 so we get some validation images, because we set up in our solver that we would do 1,000 iterations per validation. Once it's done 1,000, I'm going to switch it to a time lapse so we don't have to sit here for 30 minutes while it trains. We'll let it do the first bit so you can see what's going on. You have a few options when you're training. When you've got lots of channels, you can't really plot too much, so we just have a selection of accuracy and we haven't got any data yet, so we're not going to get anything until we've actually been through a few validation passes. But well, it's a bit tedious watching this, so I'm going to set the recorder up to do more time lapse. Let's pause it while I do that. A bit embarrassing, I forgot to turn the mic back on, so I'll have to do this a little bit over. So we've trained it, and I had demonstrated that you could name the channels here. So instead of just seeing channel 1, channel 4, you actually get the name. So, it's not a dog, it's a dog. Okay. It's just okay. That's good. Now we're going to have a test run, and we're going to select the test images folder. These are data that the network has not seen. It's not part of the training or the validation set. It's a separate set of images that CFAR gives you. So we'll give it a go with that. Okay, got the first one pretty right. And I did add a version of this which was RGBA to just make sure Delve is handling the conversions of the image formats correctly. So it's expecting RGB 24-bit per pixel, but in case you're sending it an image that was RGBA, it should still work, and sure enough gets the same result. This one has an alpha channel, and Delve removes the alpha channel, so it can be processed. Okay, we whiz through. Ship. Sure, I wasn't too convinced about that, was it? I like that one. I guess that could be a bird or a frog. Some of these images are a little dubious. Let's whiz through to something a little bit. Okay, trucks, cars. If trucks and cars are a bit confused. We didn't train it for very long though, it's not to be unexpected. Let's whiz through a bit more. Let's see if we get to a different section. Airplanes. Yeah, not too bad. Oh, I think that one's a dog. Okay, keep going. Let's zoom through, see if we can find some other kind of images. They're all kind of alphabetical, so everything kind of begins with an A, an airplane. I think that one's a bird. Yeah, it could be. Keep going. Let's see if we can get through to more birds. Okay. Don't see how that's a bird. Huh. How that is a frog beats me. I don't know what that is. Well, you get the idea. Okay, there you go for CFAR. Next one we'll do a UNet image segmentation. Much more fun.